Stangibelisco here. I'd like to explain the meaning of a term you'll often hear in electronics: current drain. It can be confusing because it can be confusing in the same way that the term voltage drop can be concerning. Concerning too, by the way. If it's confusing, it's concerning. But anyway, voltage drop doesn't happen because you drop something and it falls on the floor. Well, current drain doesn't happen because something goes down the drain and into the sewer. Not exactly, anyway. Current drain is basically the amount of current that a particular device or component demands from a source of voltage or power. Like if you have a battery and it's 12 volts, a 12-volt battery, and you have a 3-ohm resistor connected across that battery, then Ohm's law will tell you that the current I equals E over R, the voltage over the resistance. In this case, 12 over 3, or 4 amperes. So the current drain in this particular situation, assuming direct current, is 4 amperes. And now you may have a circuit such as, a device such as this lamp this lamp over here. It has let's see, 6 volts in it. That's 4 1.5 volt AA size flashlight cells connected in series to produce 6 volts. And then that 6 volts is applied through a certain resistance, I assume, across the light-emitting diode array that provides quite a lot of light for a very low current drain. I don't know what the current drain is in this particular situation, but it's a lot less with these light-emitting diodes than it would be with, say, an incandescent lantern bulb. That'd be about the only alternative in a case like this. The trend, of course, lately in recent years has been to go to light-emitting diodes, LEDs, for sources of light because they provide so much more light for so much less current drain. Now, I don't know how much current this iPad on which I'm recording this video demands from its battery. I don't even know what the voltage of the internal battery of the thing is. But the current drain is however much current this iPad is demanding at any particular moment from the battery. That's what current drain basically is. Current drain can take the form of dissipation, in which case it just dissipates as heat like in a resistor, or it can take other forms such as light and heat, such as come out of bulbs of all kinds, or some of it can even take the form of radio frequency electromagnetic waves, such as might come out of your ham radio transmitter. But of course, not all of the current drain demanded from the power supply in your radio transmitter goes into electromagnetic radiation. A lot of it goes into heating up resistors and operating various other components. But that is what current drain means. Another term is draw, like you draw on a blackboard. It's demand, current demand, the current drawn from a device or battery. The current drain is the amount of current drawn or demanded in a situation. and it's usually used with reference to direct current, although it can apply to root mean square alternating current as well. Stan Gibilisco signing off. Until next time, so long.